So last class, we covered three kinds of reflections, right? We have the first rule here. I'll highlight that. So make sure you repeat each sentence several times, okay? Negative with y, reflect over x-axis. If you have negative with x, reflect over y-axis. If you see an inverse, then the function will reflect over y equal x, okay? So anything that's movable, right, you have to move it to the y side, okay? Usually you can tell by looking at the basic, right? If the basic is a radical, that means anything inside the radical has to stay with the x. Anything outside the radical, it will be movable, right? So we have 6 basic functions. When you start the question, you need to see which basic are we dealing with, right? If it's a quadratic, and if there's anything that's stuck inside the bracket with the square, right, inside the square, then it's with the x, okay? For absolute values and radical, they are easier to tell, right? Because you have kind of like a bracket. Square root is kind of like a bracket as well, okay? And exponential similar too, right? If it's in the exponent, then it has to be with the x, right? So the one that's more difficult will be the cubic and the square. You need to look for brackets. Okay, so Marcus, do you have question about the homework? You just joined in.
No, not right now. No.
Okay, then you need to hand in your homework. I haven't got yours yet.
Yeah, I have like a few questions to do still.
Which ones?
It's the last few.
Okay, do you need help on those ones?
No, I can finish it.
Okay, all right. All right, so let's continue with the lesson here. All right, so that everyone please turn to page 20. So for 20, we chose the quadratic as our basic. Okay, so once you recognize, okay, it's a quadratic, then your form will look like this. The y equals to x squared, right? If it's basic, then it's just simple y, right? And then simple x. But then we're going to add stuff into the brackets to make the graph look differently, okay? So in our first example here, we have a 2, right? A 2 in front of the x squared, and that 2, because it's outside the square, right? It's not affected by square. So if you move the 2 over to the left side, it will be y over 2, right? You see over here, y over 2. So there's a 2 underneath the y. When that happens, then you will say it's vertically, right? I'll highlight that. Will be vertically expand by 2, or you can say stretch by 2, okay? So all the y value is affected because it's with the y, right? With the y, it will be vertically expand. And with the y, it will also affect the y values in the table. Okay, so that's where we left off last time. We'll continue with the next example, right? So let's erase that. So this part is the y part. This part is the x part, all right? So if you look at this example now, you have an extra 1/2, okay? This 1/2. Is this 1/2 movable to the y side? Daniel?
Yes.
Okay, and if I want to move it over, how can we do that?
You divide by 1/2 on both sides.
Right, okay, so for the y part, what would it look like then?
2y equals x squared.
Okay, so become 2y equal to x squared. How did you get 2y?
So y divided by 1/2 equals so it becomes 2y because you have to like flip, I guess. So
Okay,
it
very
becomes
good.
y times 2. So
That's
it's
right.
2y.
Good, good, good. Okay, so I'm gonna show a few steps, okay, just in case some people didn't miss how to get the x squared. So if I want to move the 1/2 to the left, okay. Right, I need to divide. Okay, divide both sides by 1/2. So it will look like y divided by 1/2 equals to the x squared. Okay, so of course on the left side, when you take y divided by 1/2, it'll be the same as y times, okay, y divided by 1/2 will be the same as y times 2. So it will look like, okay, y times 2 will be 2y, right? So you can write as 2y equals to x squared. Okay, so you can either leave it in this form or in this form, but I prefer the one in the red box. Okay, this is called the story form. Okay, please copy this down first and raise your hand. Just want to make sure everybody's on the same step. Okay, please raise your hand if you copied everything on the screen right now. Okay, Angela and Jocelyn, you done writing? Okay, so why do I want to keep it as y over 1/2 and not 2y, right? 2y looks simpler because the number that we're going to use for describing the transformation, okay, how it's got transformed is the number that's underneath. So I'm gonna circle it, okay? So the 1/2 is the number that will be used, or we'll be using to describe, okay? Because the half is just like the previous question, the 2, that's under the y, right? So 2 is the number that will multiply all the y values to get the new ones. So same with this question, right? You have a half. So that half is going to help us to get the new y values. So you take that 1/2 and then you multiply the basic y values. Okay, basic y value means the top ones. The 4, 1, 0, 1, 4, those are the basic one, right? So because it's under the y, so it will affect the y values. And when you take a number times it by half, will it get bigger or smaller? Evan?
It'll get smaller.
Yes, okay. So can you tell us what are the new y values now?
2, 1.5, 0, 1/2, and 2.
Yeah, okay. 2, 1/2, 0, half, and 2. Okay, so you take the original basic y values and then you multiply by the number underneath the y. Okay, that's how you get a table, right? So because it makes all the y value gets smaller, that means your graph will be shorter, okay? There's nothing happening on the X part, right? Inside the bracket for the X, there's nothing extra, right? So X has nothing changed. So it will stay the same as the basic, right? So we'll write it as -2, -1, 0, 1, 2. Okay, I will just change, keep it consistent, okay? We'll use the red color. 2, half, 0, half, and 2. Okay, so let's graph it out. So -2 and 2 will be here. -1 and half be here, right? Compare with the points that we had on the top, okay? The basic functions. Here and here and 2, 2. So it goes up slower, right? It's still rising up, it is still opening up, but it goes up half. The speed is half. You can say it's like rising up speed, right? It rises up only half the speed as the basic. Okay, can you raise your hand if you finish writing the graph, drawing the graph? Okay, please raise your hand if you finish the graph, and then we'll talk about how to describe, right? Okay, Eric and Angela, are you done?
Almost done.
Okay. So far, everything affects the Y values, all right? Okay, so because it's affecting the Y values, right? So it's affecting the up and down, right? Because Y goes up and down. So the way to describe is still vertical, right? Vertical means up and down. So vertically, now because it's getting smaller, so instead of saying expand, we have compress. Okay, vertically compressed by 1/2. Okay, so this time you will say by 1/2. So that's why I don't want to write it as 2y, because 2y is not the 2 is not the number we use. We don't say compressed by 2. Okay, so I want to keep the number under the y, so that it will be the same number that we use for the description. Okay, so that's the form we want to keep it in. We call that the story form, right? So when you answer, you will just say vertically compressed by 1/2. So remember the rubber band analogy, right? On the top left, this is the basic, right? On the right side, this is expand. This is what we did last time, right? If it's compressed, then you have to push down. Okay, this will be compressed. Okay, it'll be going this way. Vertically, okay, vertically compressed. Expand, right, going this way. Okay, I erase this. Okay, basic means nothing happened. Expand vertically, you pull the rubber band up and down. Compress vertically, you push the rubber band vertically, right, up and down vertically. Any question about this part? Vertical is the easy ones, okay? Because you just move it over to the Y side. All right, so let's look at the next section. Okay, so this part, y equal to bracket x over 2 squared. Okay, so you can see that compared to the other two questions we did, we don't have an extra box to write, right? Because this one, it's already in the story form that we need, right? This is a quadratic function. So the y part is clean. And the extra 2 is with the x, right? The 2 is inside the bracket. So you cannot move it to the y side, okay? This is not movable because it's inside the bracket of the square. Okay, so you don't want to evaluate it, okay? You don't want to turn it into x squared over 4, okay? If they give you the question like this, you just work with what you have, okay? Don't move it. Otherwise, you will get a different story, okay? Different description. Even though the graph will look the same, but that won't be the answer that your answer key is looking for, okay? So it's not movable this time, so that means it's gonna affect the x values. Okay, so it will, this time instead, we will multiply the basic x values. Okay, so very straightforward rules. If it's with the y, you change the y values. If it's with the x, you change the x values. Okay, so can you guys please write down the new x values? All right, so all the basic x, okay, so this time I'll use the green, okay? All the green numbers, you will need to multiply by 2, all right? Multiply by the number that's underneath the x. So once you've done that, please raise your hand, okay? Get the new x values. And does anyone have questions? You can turn your mic and ask me. Okay, Caleb, how do you get the x values?
Oh, I'm still working on it. Give me a second.
Okay, let me know when you have the answer. So Caleb, do you know what to do?
Yeah, I'm almost done. Almost done. Okay. I think the numbers should be -2, -1, 0, 1, and 2.
That's your answer?
Yeah,
How did you get those ones? How did you get it?
because it's just the numbers that we usually use, so I was more comfortable using them.
Okay, did you see I wrote down multiply the basic x values?
Oh, no.
Ones are called the basic x values.
Oh, Oh, so multiples of 2.
The basic values you need to look at the very top. Okay, these are the basic value in the green. Okay, what the numbers are they? Can you say it out? Caleb, please keep
Negative.
the mic on.
Oh, okay. Negative 2 and 4 minus 1 and 1.
But just
0
the
and
x
0.
value, just the x values.
Oh, negative 2 minus 1, 0, 1 and 2.
And those values are called,
Oh, the basic x values.
yes, okay. So now if you look at the question here, what's the number under the x?
Oh, 2.
So you take that number, multiply with the basic x values,
Oh,
okay, to get the new ones. So please
Okay.
tell me right now, what will be the new values?
Negative 4,
Go on.
negative 2,
Mhm.
0, 2 and 4.
Yes, okay, very good. So you just take whatever number that's under the x and then multiply with the basic. Okay, Caleb?
Okay, sure.
Yeah, okay. So for the y values, do we have to change anything, Nick?
No.
Nothing, right? On the y part, it's very clean. So the y values will be what, Evan?
The same. So 4, 1, 0, 1, 4.
Yes, okay. Yeah. So very simple rule. If you see something extra under the x, you change the x value. If you see anything that's under the y, you change the y value. If you see both, then you change both, right? So I try to make the rules easy to remember. So those are the points that we use to make the graph, all right? So please draw the graph now, okay? And raise your hand when you finish the graphs. Negative 4, 4, be up here. -2, 1, 0, 0. Okay, please raise your hand if you are done. 4, 4. Okay, so we are comparing with the basic, okay? When we describe, we are always describing comparing to the basic. All right, so please raise your hand if you finish the graph. We are gonna describe what's happening here, okay? How do we describe the transformation? Does anyone want to give it a try? Like, how would you describe?
Can I give it a try?
Yeah, sure, Philip.
Would it be horizontally expand by 2?
Very good, okay. How do you know it's horizontal, Philip?
Because it's going more to the left and right rather than more like towards the center and upwards.
Yeah, okay. Well, this one, right, if you think about vertically compressed, it's kind of like getting wider as well, but it's getting wider differently, okay? So it's being pushed down. So it's like when you have a ball, right, a basketball, or right, you can make it a balloon. I think balloon will be easier, right? A ball will be difficult, right? You can make it squished by pushing it down, right? Then it will become this, right? That will be called vertical. But I can reach the same shape. Instead of pushing it vertically, I can also make it the same shape by pulling sideways. Then I can also reach the same shape, okay? Both of them are getting wider. But If it's with the y, we have to use vertical. If it's with the x, you have to describe using horizontal, okay? So if it's, so these two graph, okay, these two graph, even though they are both, right, these two graph, they are both getting wider, but their points are not the same, okay? All right, so let's describe it now, okay? We'll write it down. So this time, because it's under the x, so it'll be horizontal. Okay, horizontally. And then it will be expanding because the number 2 will make numbers bigger, okay? So it will be horizontally expand, or you can say stretched by 2. Okay. So always focus on the what's the number under the x or under the y. That will be the number that you use. Okay. So if you see a number, for example, like if the question give you something like this, 2y equal to x squared, then you vertically expand by 2, that will be wrong, right? You have to rewrite it. So it becomes y over 1/2. And then the correct way to describe will be vertically compressed by 1/2. Okay, you cannot say vertically compressed by 2. Okay, by half. So number beside the variable is not the form we want. Okay, you need to move it down. Okay, this part very important. Okay, can you raise your hand if you understand up to here so far? If it's 2y, you need to move the 2 under. Okay. So therefore, if you understand that, we can look at this more in a more easy way, right? So instead of 2y, we have 2x now. And this 2 is not movable. Okay. Why is, how do I know the 2 is not movable? Marcus?
Because it's in brackets.
Very good. Okay. So 2 is inside the brackets, so it has to stay with the x. But we cannot have 2x there, right? We cannot have the 2 beside it. We need to move it. So how do I move it now, Lily? How do I move it under the x?
To 5, 2.
If you review the top questions, right? If you have 2y, you see a 2y.
Yeah.
Okay. If I want to move the 2 under, it will become
Divided by 1/2.
1/2, yeah. Because when you divide by 1/2, it's the same as times 2, okay? So similar with this one, you have a 2x, and if I want to move the 2 under, it will become what?
X over 1/2.
Yeah, okay. So remember, you need to flip the number, okay? Or x over 1/2. Because the 1/2 is the number that's affecting the y value, not the 2, right? So that's why we move it over. The y, nothing happens. Okay, so for example, okay, just an extra example, if you see something like this, y equals to 3/2x squared, right? So 3/2 is for the x, right? It's inside the brackets, non-movable. So if I want to change it into the form that we want, you need to move the 3/2 under. So it become x over 2/3. Okay, so you need to know that when to flip it. Okay, if you have a number beside the x, you want to move it under, you need to do the flipping. This is the only one you need to do the flipping, okay? If it's with x. can make a start here, okay? The other ones, you don't really need to do the flipping, right? Because if the question already leave it under, you just keep it there. For the y, the 1/2 you can just divide over and it will be under, right? No flipping. Same with this one, okay? Try to look over these 4 examples. The last one is the most special one. Okay. Right, so the 1/2 is the one that we are going to use. Okay. Okay, so the 1/2, we'll take that to help us get the new x values, just like before, okay? So multiply basic x values. Okay, so please raise your hand if you finish all the points, the x part and the y part, right? Okay, please raise your hand if you finish the table, the whole table, both the x and y. Okay, so Caleb, can you try one more time for the x? What's the new x values now?
-1, -1/2, 0, half, and 1.
Very good. Okay, you got it this time. And Eric, what about the y values?
I have 4 and then 1 and then 0 and then 1 and then another 4.
Yeah, okay, so the y values stay the same, nothing happens to it, okay? Of course, in the homework, sometimes you might have to change both sides, okay? Change the x, you have something under the x, you also have something under the y, so you need to multiply both sides of the table, okay? So let's graph it out, right? So -1, 4. -1, 4, right? You can see very skinny this time, right? -1/2 is 1, 0, 0. The other side is symmetrical, right? So it should be very easy to complete. Okay, so it does similar things as the first graph that we did last class, right? The vertical expand by 2, right? You can compare these two, right? Both gets taller, but in a different way. Okay, so if we draw the balloon thing, right? If we draw the balloon thing, so basic, and I want to make it taller, you can do it differently. You could squeeze sideways. That's what's happening here, right? We make it horizontally compressed, because it's half compressed. Okay, that's one way, right? Or you can make it taller by pulling up and down, right? So both ways is making it taller, but the idea behind it, right? The process of getting there is different. So their final graph doesn't overlap, okay? Even though, right, if you look at the first one, you have a 2, expand by 2, vertical expand by 2. And this one we just did is horizontally compressed by half, even though they both has to do with the 2, but their graph, they do not overlap each other. The points are at different place. Okay, so I already gave away the answer here, right? So how do we say this one, Susan?
Horizontally compressed by half.
Yeah, horizontally, very good. Totally compressed. Okay, I know it's compressed because it makes the number smaller, right? When you times it by 2, it gets it bigger, right? So expand. Times it by half, it gets smaller. Just compress by half. All right, so please raise your hand after you finish writing everything so far. And then we need to make a summary, okay? Make a short summary before we practice some more examples. Okay, please raise your hand if you copy everything here. Make sure you have a very good notes, okay? Especially if you are not taking grade 12 right now, right? You're gonna take it next year. You'll need to have a good notes to review, right? The videos will still be on. So if you need to rewatch the lesson, right, you can go back. Okay, are you done copying? Please raise your hand. So the yellow part, right, the sentence that we wrote down, those will be the answer. Okay, when they say, please describe the transformation, this is what you write. Please raise your hand if you finish writing. Okay, so let's make a summary now, right? So we'll go back to the last page first, okay? So far we finished reflection and stretching, right? Or shrinking. So for reflection, okay, we'll put it down here at the very bottom. You should have a space. Reflection, I use R. Okay, so the first rule, negative. Okay, I'll write a word. Okay, negative with X reflect over Y-axis. Right, first one. Negative with Y reflect over X-axis. Okay, and then third one, inverse, right? That means the X, Y got switched. Reflect over Y equals X. Okay, so this is for the R. R stands for reflection. We have 3 kinds of reflection. So the yellow highlighted is the thing that you answer. Okay, Negative with x is for you to determine. Okay, it's reflect over y-axis. So this is that's a conclusion for the reflection part. Okay, so please raise your hand if you finish writing this part. And then we're gonna make a summary for the stretching or expanding, compressing. So do not mix this one with the stretch, okay? So negative controls the reflections. And when you are looking at the stretching, you would ignore the negative sign, okay? For a moment, when you are trying to think about stretching or compressing. Okay, please raise your hand if you're ready to move on to next page. Are you done, Eric?
I'm just copying down the last one.
Okay. Inverse reflect over y equal x. Okay, so for the last page, page 20, right? So we only have two rules, okay? Two rules for the stretching. So let's write it here at the bottom as well. For the S, okay, our first rule is to identify whether it's vertical or horizontal. Okay, so Angela, how do we tell it should be vertical or horizontal?
If like the number is with the y, then it's vertical,
Mm-hmm.
and then if it's with x, it's horizontal.
Yes, okay, and make sure the number is under the x and under the y, right? So sometimes you might need to do the moving, right? Like the first question, this 2, we need to move it to the left side and make it go under. This one as well, the 1/2, I need to divide it over, make it go under the y, okay? This one, however, the 2, you don't need to move it at all. It's already under the x, so horizontal. This one, the 2 is not under, right? So we have to move it under and make it flip, okay? You call that reciprocal. You need to flip the fraction to make it go under. So you should look at the number that's under, right? If the number under the x, okay, if you see a number under the x, that means you have a horizontal. Okay, if you see a number after you move it over and it's under the y, then you know it's vertical. Okay, x is horizontal, y is vertical. Just like the way the axes are, right? So very straightforward. Second rule is to talk about whether it's expand or compress. Okay, so we have some question that's expanding, some question that's compressing. Okay, how do I know if we get an expansion or compress? Okay, Jenny, what do you think? What will be the rule to tell if it's expand or compress?
If the like points are closer to each other on the x-axis, then it's compressing, and then if it's further away, then it's expanding.
So that means you are looking at a graph. Is it?
Yes.
Okay. Is there a way I can tell by looking at the form, the equation that they give you? For example, like the ones on the left side, they are both expanding by 2. The ones on the right side, they are compressed by 1/2. How do I know if the numbers expand or compress?
Like
What if the number is like 7? Would that be expand or compress?
it would be expanding because it's bigger than the like basic values.
Basic values, you mean the basic tables?
Yeah, the basic table.
Sort of. Okay, it's not really the basic value that you compare with. Okay, but it's good that you need to think about the basic. Okay, let's think about what number would you multiply. Okay, I have another question. So for Lily, okay, can you think about what number do you multiply? It will make it bigger.
2.
Yeah, 2 or anything times 2 will make it bigger, right? 3 times 2 will become 6. 7 times 2 will become 14 and get bigger. But is 2 the only number that will make it bigger?
No.
What other number will also make it bigger?
3, 4, 5, 6, 7, and above.
Okay, so what kind of number in general? Can we have a rule? What kind of number, if you multiply, will be bigger?
Number greater than or equal to 2.
Okay, what about like 1.5? If you multiply by 1.5, would it still make it bigger?
No. Wait,
So
yes.
So for example, if it's 2 times 1.5, what would that be?
Three.
3, right? Does that get bigger?
Yes.
Yeah, okay. So not just bigger or equal to 2, right? So what kind of rules should we use?
1 x greater than 1.
Has to be bigger than 1, right?
Yeah.
Yeah, okay. So you can think of it this way, right? If you take a number, times it by 1, no matter what number you pick, right? You pick, let's say you pick 7, 7 times 1, it doesn't change. 11 times 1 doesn't change. Even decimal, okay? Anything times 1, it won't change. So it's like the balance, right? The balance point. So if it's bigger than 1, then it will make the number bigger. If it's less than 1, it will make the number smaller. Okay, so that will be the rule for deciding if it's expanding or compressing. Okay, so first of all, you got to ignore the negative sign because negative controls reflection. Okay, so ignore. Negative. Okay, and if the number that's under the x is bigger, okay, this is bigger, right? Greater than 1. Okay, that's right in words, okay? So you guys don't get confused. If the number greater than 1, the number we are referring to is the number under, okay? Under the variable. If the number is greater than 1, it will be expand. If the number is less than 1, it will be compressed. But you need to ignore the negative sign. All right, the negative is for reflection. But when you're talking about stretching, okay, expanding or compressing, you need to ignore the negative sign. Right, so this is the rule. And when you're answering, you are just answering horizontally expand or compress, right? Or vertically expand or compress. Okay, does anyone have questions about these two rules? Okay, please raise your hand when you finish writing these ones. And then once you got these sentence down, okay, I would like you guys to grab a piece of scrap paper, okay? I'm just gonna make up a few questions first to practice, okay? To practice these rules. So please raise your hand once you finish writing these ones. So make sure you memorize the rules, okay? The rules for reflection, right? At the bottom of the page. And then the rules for the stretching and shrinking, or you call that expand or compressing. Number under X, horizontal. Number under Y, vertical. Number greater than 1, expand. Number less than 1, compress. Okay? Because when you times it by 1, no change. So 1 is like the border of getting bigger or getting smaller. Okay, Jenny, are you done writing?
Almost.
Yep. Okay, I'll add a page on the side. Okay, so try to memorize these ones and then do the answer the question without looking at the rule. Okay, so usually if it's in-person class, then the whole class has to repeat these sentences, okay, together, and then somehow point out and then try not to look at your book. Please say out, recite the rules, okay? So you guys can try it right now, okay? So look at the ceiling, okay? Close your book and look at the ceiling. So reflection, right? We're negative with X. So think about what happens. Negative with Y. What's the rule? Okay. Inverse. What happens? Right? And then now we have the stretching. Okay, don't look at your book. Okay, try it out. Stretching, first one, number under X. What does that mean? Number under Y. What does it mean, right? Number greater than 1. Number less than 1. Okay, try to test it out, right? Because on the test, this is what's going to happen. There's no book to look at. You need to know these. I already condensed the rules, right? Just memorize these keywords. So as we go along, okay, I'm gonna make up a few questions and then I'll be asking you guys to answer me, right? What kind of story you have. And you don't have time to flip back, okay? To look at the notes, which rule, what page, right? You gotta keep it in your head. So let's try these ones. So you can write these down on the separate sheet of paper, okay? Just scrap paper. So first one, let's say we have I'll start with a basic one, simple one, okay? Okay, so I'll give you a minute. Please write down the kind of reflection you have, the kind of stretching or shrinking you have. Okay, and you will need to change it into the story form. Okay, story form means after you move it over, move things that's movable, move the number underneath if possible, right, if needed. Okay, so please raise your hand when you finish. Oops, where'd it go? Okay, when you finish writing it. So for R, you just tell me reflection over something, okay? For stretch, you just tell me if it's vertical, expand, compress, or horizontal, expand, compress by something, okay? So this is the kind of homework you will get, okay? So I'm going through this to make sure you know what to do on the homework. So you need to show me story form, the R and the S. If there's nothing for the S, you just say none. Or if there's no reflection, you just say none, okay? No reflection. Okay, just question 1 for now. Okay, so please raise your hand if you have answer for number 1. Okay, do we have everyone finished trying question 1? Okay, so let's check the story form first, all right? Caleb, can you tell us your story form?
Is it, give me a second. Let me just, is it, negative y is equal to square root of 5x?
It's good that you move the negative over, right? Very good, but it's not the final form that we want. You know why?
Oh, squaring it?
No, you
Squaring.
cannot change. You cannot change the square root. If it's square root, it stays as square root. Don't get rid of square root. So what else is still need to be done?
I'm not so sure.
Do you have a number beside the x?
Oh, over x divide over 1/5.
That's right, okay? If there's number beside the variable, you need to move it under, okay? So the final form, okay, for your story form should be x over 1/5. Okay, so this question has to do with the radical function, right? So you must keep it in radical, right? In radical form. You cannot square both sides, try to get rid of radical, then you change the question, right? Question tells you, oh, we have a function of radical. Right, so the y part has a negative, right? The x part has a 1/5. So now we need to describe the reflection. Okay. Jocelyn, what kind of reflection do we have? Jocelyn, yeah. I cannot hear you. Your microphone.
Can you hear me now?
Now it works, yes. Okay, can you try again? What's a reflection? Jocelyn?
Yeah.
Yeah, what kind of reflection?
I'm not sure.
Did you have the story form?
Yeah.
Okay, so in the story form, do you see any negatives?
Yeah.
Where?
It has a negative y.
Okay, so what's the rule if you have negative on the y?
Reflect over y axis.
Can you say one more time, slowly? You are breaking up. Can you try one more time? What's the rule for negative on the y?
Negative with y reflect over x-axis.
Okay, so when you write the answer, what do you write? You would write what?
Reflect over x-axis.
Yes, very good. Okay, reflect over x-axis. So you just tell, right? Try to find out where is the negative sign. Okay, Jocelyn.
Okay.
Okay, and how do you find the stretch or expand or compress? Do you know how?
Yeah.
Yeah, how do we tell? What's your answer for the stretching? Is it vertical or horizontal here? I can't hear you.
It's
Yeah. It's what?
horizontal
Okay, how do you know it's horizontal?
because it has a negative sign.
No, nothing to do with negative. Negative is for the reflection. We are done with that. You look at the rule on the last page. At the bottom, did you write that down?
Yeah.
Okay, how do you know it's horizontal? What's the rule say? What does it say here? Can you say it out?
Number under X is horizontal.
And
Uh,
number under,
number under Y is vertical.
yeah, okay, so over here in the question here, where do you see the number? Which number are we talking about?
It's the number is under X.
What number is under X?
5.
1/5.
Yeah.
Okay, that's the number we're talking about. It's under the X. So if it's under X, it will be,
Vertical.
look at the rule again, under X.
It's horizontal.
Yes, okay, so horizontally, and then how do I know if it's expand or compress? What's the rule say? Just
Horizontally compressed by 1/5.
because? How do you know it's compressed? What's the rule? Why not expand? Justin, how do you know it's compressed?
Because the number is less than 1.
Very good, okay, 1/5 is less than 1, so compressed by 1/5. Okay, understand, Justin?
Yeah.
Okay, so you just look at negative for reflection, look at the number under for the expand or compression. Okay, I think let's take a break, okay? And I will continue these exercise after the break, right? So I'll see you guys at 11 o'clock. If you have any questions about anything so far, you can ask me during the break. Okay, and if you haven't handed in the homework, please do now.